Okay, so here's our practice quiz. Usually we go over this in class, but neither Mr. George or I are here today, so therefore we'll have to resort to this. Anyway, we are asked to determine whether the dilation from the figure on the left to the right, so we're going to go from left to right. Is that an enlargement? Again, our two choices are enlargement or reduction. So in this case, do we get enlargement gets bigger? Again, if we're just adding some notes to this was not required of anything that we did. I'm just adding that on there just to, if you want to look over this as a quick review, you have all those things there. Anyway, when we figure out what my scale factor is determined by taking the image and placing the size of an image over the pre-image. So that means that it's where we end over where we began. So in this case, we're going to go from a bigger, we have a bigger object here on the left. I don't know where it went. I want that guy. There we go. So over here on the left, we have a large quadrilateral. We got smaller, so therefore that means that this is a reduction. And we ended with 12, and we began with 18, so that means it's 2/3, and that falls in line with what we know. We know a scale factor of a reduction has to be less than 1, so that is the 2/3. If it's an enlargement, it's going to be greater than 1, which is what this one turns out to be. We're going to get bigger, so that means this is the enlargement. With that enlargement, to find my scale factor, I ended with 22. I began with 5.5, so that means that we divide that out, and that turns into a 4. So my scale factor is 4. Again, meeting what we thought it would be, a scale factor greater than 1 causes the enlargement. Next, we rotate into quadrilateral similar figures. So here it's just asking us to match up parts. They are similar, so that means that similar parts, angles are congruent, sides are proportional. So I'm going to look, again, this goes in order, QRST. This went in order, QRST. So that means that it is going to be super easy because the first figure, the first vertex in quadrilateral 1 is going to match up with that one there. So we know it's going to be W, and we can just go from there. So it's going to be W, X, Y, and Z. Again, like parts are going to match up. So over here, when we talk about the proportional sides, QR is going to be my first 2, though that means it matches up with WX, my second 2. So there's a WX segment. XY is the middle 2, so that corresponds with RS. ST is going to be the last 2, so that means that has to be YZ on the other one. And lastly, WZ is front to back, and that means that QT is going to be front to back. So again, that was fairly straightforward. As well, number 3 is, again, we are going to write a similarity statement. The other one started with L, went to N, P, and then Q, so we have to go in that order on the other one. They appear to be oriented the same exact direction, so that means that I am going to start with T, and we'll go U, V, W. So the quadrilateral in question will be quadrilateral T, U, V, W. All right, number 4 and 5, I'm going to get a little bit picky on this one. I'm going to model exactly what I want to see on the quiz, so because you have to show me why or why not. Okay, so when we talk about are they similar, that means that are they similar? Angles are congruent, not pi, wow. Angles are congruent, sides proportional. All right, so to be a similar figure, we have to meet those 2 criteria. So here we go. In number 1, you have to show me that the angles are equal. So you need to show me that somehow P, S, W, and Z are all equal because they have the single arc mark. Okay, you have to show me that. You can't just assume it and just move on. Since both of those, all these are double angles, we're good to go there. So circle them, draw a statement like in the previous 2 problems ago, do something, but you got to show me the angles are congruent. Okay, next is we're going to show that the sides are proportional. So it doesn't matter the order in which we go. I'll just go left to right because I find that easier. Or just do shortest to shortest, etc. All right, we'll talk about that. Shortest to shortest means shortest is 34, shortest is 68. The next one's going to be matched up with the top. The next shortest is going to be 42. It matches up with 84. The longest sides present are going to be 84. It's the same on both sides, so I only have to do it once, but 84 to 168. So we can look and reduce, and that reduces down to 1/2, that reduces to 1/2, and that reduces to 1/2. So since my sides are all in the same proportion, we know that these are going to be similar figures. And lastly, we had one other statement. No, we just had to state the scale factor. So the scale factor is 1/2. Okay. On the next one, again, looking at angles. Angles is going to be easy on this one because all of them are right angles on the left. All of them are right angles on the right. So all angles equal 90. So therefore, that's not going to be an issue. So here we go. Let's compare the shortest side again. So shortest side is 16. Shortest side is 3. Shortest side, the next longest side I'm given is 32, and then 8. So now we're going to see if those are equal. So this is going to give me a 5.3. This is going to give me a 4. So therefore, these two rectangles are not similar. Okay, but I've just modeled exactly what I want to see. So there's going to be multiple points within here. Like this is going to be a 3-point problem. You got to show me angles, you got to show me sides, and then you got to make a conclusion. Okay, so that is what you have to be able to do. And then this one's going to have a 4th point over here because, so this would be 1, this would be 2, this would be 3, 3 for the similar, and then 4 for the scale factor. All right, so know that that's going to just be multiple points. Moving on through this, now to me this is the easy part. We're going to, x is to 6 as 25 is to 10. So again, we're just matching up corresponding parts. The left side, it's oriented the same, making it easy. X is to 6. The other portion that we make, 25 is to 10, and now it's just cross multiply and divide. So that means that 10x is going to equal 150. And then we divide by 10, x is going to be 15. It said find the value of x was the requirement of the problem, so hey, we're done. Easy peasy lemon squeezy. All right, and next, they said the polygons are similar to start with, so we just have to match up the right parts so that we have, and the problem is it didn't give me any type of similarity statement, but it appears that everything, the two right angles, if I could just take this guy here and rotate it over 90 degrees, it would match up. So that means that 2x minus 2 is going to match up with 12. And 2x plus 1 is going to match up with 18. So there's what we are going to match up as far as corresponding parts go. I guess I could have highlighted that. 2x minus 2 is going to match up with that 12. And then the 2x plus 1 matches up with the 18. So anyway, there we go. We're getting ready to solve this, guys. So I lost my... how did I lose my black? I don't know. I digress. Anyway, here we go. We're going to take and we're going to cross multiply that. Oh, because I'm talking about a highlighter, not a pen. There we go. Sorry. I'm looking at my pens going, why don't I have this color? And you don't care right now. I get it. 36 minus 36x minus 36 is going to be the left. We're going to do the same thing. We have to distribute the 12, so that's going to be 24x plus 12. So that means that I'm going to subtract the 24x over and get a 12x. In the same process, I'm going to add the 36, and I'm going to get a 48. I did not leave myself enough room, but if I take 48 and divide by 12, it turns out that x is equal to 4, and that's what I needed to know. Moving on to the similar figures. Again, we're going to compare like parts. 4 is to 6 is the bottom edge. Like areas are going to be 336 to the unknown because I don't know what the area of the right figure is, but that's what I'm asked to find. So, but what I have to remember is this is surface area. Area is 2 dimensions, so I'm going to take that ratio and square it. So 4 squared is 16, 6 squared is 36, and then we're going to have 336 over x. We continue our process of cross multiplying and dividing. So that means that 16x is going to yield some unwieldy number as far as 36 times 336, which is 12,096. Then we're forced to divide by 16, and x will become, whatever that value is, 756, and then we're going to have meters squared. Okay, again, it's like a point for setting it up, a point for doing work, and a point for the right answer. Each one of those is going to be worth 3 to do that. So on the number 9 over here, again, we're going to, like parts is 10 is to 12. Like volumes is 7850 to x. Now, since it is a volume, my scale factor has to be cubed in order to become a volume ratio. So we have that. So there's 1,000 over whatever 12 cubed is, and that's 1728. And again, cross products. And if I thought the other product was unwieldy, this one is really unwieldy. When we take 1728 times 7850, it is 13,564,800. Now the cool part is we're going to divide by 1,000, which is going to be easy math, because all we have to do is move that decimal back 3 places. And so that means that x is going to be 13,564.8, because all we did was slide it back 3 places. All right, one more to go, and we can stick a fork in me. I will be done. But where a race goes around 4 buoys, it's in a rectangular course. If the total length of the course, so the perimeter equals 2.4. Now, the thing is, we do have that perimeter ratio that we talked about last time, but this is a little bit different because it wants to know what is the length and the width of the course. So that means that we have to go with a 1x and a 2x and a 1x and a 2x, because it is rectangular. I know opposite sides are equal. So if I go with that as a total, I know I have 6 x's around my lake. So 6x is going to equal 2.4, and we get x equals 0.4 when we divide. Now the thing is, it wants to know the length and the width of the course, so that means we still have to take 1 times 0.4 to get one of the values is 0.4. 2 times 0.4 is going to give me a 0.8, and those are going to be measured in kilometers. Okay. All right, we have come to the end of that. So again, quiz tomorrow over. Again, I pull no punches. This is exactly what you have to be able to do. So we will see you tomorrow. Actually, I will see you Thursday. All right, goodbye.